Okay, so eels are washed onto a beach after a storm. Their lengths have been normally distributed with a mean of 41 and a variance. Okay, now a variance of 11 centimeters. Now we need to familiarize ourselves with this term. Variance is just this, when you get the square root of it, you get standard deviation. So it's just another way of expressing standard deviation. Okay, so the variance is before the standard deviation. The variance is the standard deviation before the square root. So you need to get the square root of this in order to get the standard deviation. So you'll see here I have my square root on that to get my standard deviation. Okay, so again here now we have a z figure. Now if an eel is so what are we asked? What probability? If an eel is randomly selected, find the probability that its eel is at least 50 centimeters long. So I'm after getting the z score of 2.71. So I'm going to mark that in here. So I'm looking at this part here. Okay, so I just want this high part here. Okay, so basically I want the part above, but obviously our tables only does to the left of that. So in order to do this, I need to do a 1 minus. So the probability that z is greater than 2.71 will be equal to 1 minus the phi of 2.71. So phi of 2.71 is the blue part. So I'm going to get 1 minus, when I look that up, 0.9966. So that's equal to 0.0034. Okay, and as a percentage, that's actually 0.34%. So there's a very small chance of getting an eel which is longer than 41 centimeters. Okay. The next one then, find the proportion of eels that are measuring between 40 and 50 centimeters long. So again, I have to get my two z scores. So my 40 z score, I have it worked out there, and my 50 z score was taken from the previous question. So I have a minus 3. Okay, a minus 0.3 and a 2.71. Okay, so any figures between the two of these. Okay, so again I set up my probability where my z is between the lowest and the highest. So we know that this is to the left of the highest minus to the left of the lowest. And again, the lowest one is causing a problem here because it's minus, but a minus z score is very easily done by 1 minus the positive. Okay, so looking up these z scores then, I have 0.9966, we had got that already, minus 1. Now again, be careful with your use of brackets here, that you have a minus in front of that square bracket that needs to be distributed. And then all of that into the calculator gives me 0.5704, which as a percentage is approximately 54.04%. Okay, so the next one then, how many eels? So the difference between this and the last one, it says find the proportion of eels. So you're just given a percentage, or you're given a probability between 0 and 1, or a percentage. This one actually asks you for how many eels out of a sample of 200. So don't forget, once you get your probability or proportion, that you convert the answer back to eels. So this corresponds to a z score of 1.21, which is here. Now it says, what does it say? At least 45 centimeters. So at least 45 would mean that we need above that. Okay, so we set this into a probability of z, which is greater than 1.21. Now we know we're in trouble here because we can't get that in our tables book because we can only get to the left, the section in blue. So that means then I'm going to go 1 minus the phi of 1.21. So that will give me the phi of 1.21 will give me the blue, and then 1 minus will give me the red. So 1 minus 0.8869, and then I get that to be equal to a probability of 0.1131. So that's the proportion of eels that will be at least 45 centimeters in length. So I need to find how many eels. So I take my 200 and I multiply it by 0.1131, and that will give me 22 0.62. So this implies approximately we will need at least, it'll be at least 23 eels.